Okay, let's read number 3 together. In a convex polygon with perimeter 100, if each side has an integral length, what's the maximum possible length of one side? So we have a polygon with a perimeter of 100, and we would like to find the maximum length of one side. So let me start out with an easy analogy, easy example. So if I say a triangle, okay, say that's side 1, so say side A, side B, side C, okay, it says maximum, so I can really distort this, meaning I can have something like, say I have the longest side C, and then, okay, let me use color. So that's A, that's C, oh, I apologize. Okay, that's C, and I'll use blue. Okay. So I'm gonna really distort this, meaning I'll try to make the longest to be C. That's our C. And if I stack A and B, say they happen to be a same length, can you form a triangle? The answer is no, you can't. In other words, the sum of the two shortest sides of a triangle must exceed our longest length. So even if it's like even if C is slightly bigger or equal, then we will not form a polygon. So what this tells us is that C in the triangle or our largest length has to be greater than the sum, has to be smaller than the sum of A and B. So A plus B have to be greater. At least you know that from geometry and SAT. But notice that lengths are really like 50-50 here, right? Like 50% and let's check out 50%. So if the sum of A and B, the lengths, if they happen to be like 50.01%, then at least, even though it's gonna look like a very flat figure, it's a polygon, meaning triangle in this case. Alright, and let's also use different polygon this time. I'm gonna use rectangle. So say I have a similar case in which the longest side now is D. Okay, maybe actually let me use different color. I'll use green. So that's D. And imagine you are stacking them up just like we did. Okay. So you have A, B, C. As long as the sum of the length of A and B and C are slightly greater than D, we have a polygon. But again, visually you will see it's like a 50-50%, the length. If the addition of all these and the length of D are like 50 and 50. Okay? What this tells us is that because our perimeter is 100, the sum of A plus B plus C has to be at least 51. Okay? And our length here has to be 49. Why? Like I said, I cannot have 50. Oh, I have a grave mistake. I should not have equal sign. Yeah. Because I cannot have 50 and 50 here. I think I'm repeating a lot because if you have 50 and 50 and our perimeter, the sum of all these has to be 100, you will not even form a small enclosure. Like you won't have this kind of bounded region. Okay, you just have two sticks and they just converge and they just become line. So it said each length is integer. Even though I could have probably make 49.8 and 51.2 for each side, that would be violating our question. So since we cannot have really 50 for our D, the maximum length, we have to step down to 49. That's the largest. Okay? In the same manner, for triangle, we can have 49 here. Now it didn't say the polygon has to be same side, so I can have something like 1 and 50 like that. Even though it's very distorted, this is still possible as long as A plus B and C equals 100. Okay, same thing. I could have 17, 17, 17, but I can also have 1, 2, and probably 48, and you need to have 49. Okay, and at least we will have a polygon this way. Now moving to number, okay, so let me answer it first before moving on. The answer here is 49. Hopefully that was clear. If not, try a few more, like a pentagon and hexagon, and you're gonna see that the maximum integer value of the largest length can only be 49. Okay, moving on. Number 4, what's the least positive integer that cannot be written as the difference between two positive primes? Now the strategy to solve this kind of problem is, try. Okay, at least prime numbers, a few prime numbers, from your memory. Start with 2, 3, 5, 7. So just to recap, the prime numbers have only two factors, one of which is the number itself and another being 1. And I cannot have 9 because 9 has 3 times 3 factor. So 9 doesn't work. 11, 13, 17, 20, 19 works. And 23, and I'll stop at 29. Okay, so just looking at these numbers, let's try to figure out the difference. Okay, I can look at the difference between these guys, right? I see 2 difference. 4. Notice after 2 we have all odd numbers. 3, 5, 7, 11, 13, 17. These are all odd numbers. From SAT Math or Algebra 1, you learn that odd minus odd or odd plus odd give you even difference. Okay, that's why you see 2 and 4, and you can also see that would be 8, and you can also form 6 this way, and you can have 10 this way, 13 and 3, the difference is 10, and so on. Okay, now let's take a look at our even number here. So the 2 is the only even prime number in our number set, and from algebra we learned even. Okay, in this case I will have odd minus even. Okay, because 2 is the smallest, we can't really add here, and also 2 is always being subtracted in this system. So if I take a look at the difference between them, odd minus even is always odd. So 3 minus 2, you get 1, right? 1, 3, and 5. Now you might wonder, do we have 7? The answer is no, we don't have 7 because it skips to 9. Unlike here, between 3 and 5 or 5 and 11, this was very possible. I could choose any term between these, or this and that, and this and 29, 11 and 17, 11 and 19. I can do that, but I don't have such a freedom. I don't have such freedom for the condition of odd minus even. We only have one even, so unfortunately we will never ever see the difference of 7 in our prime system here. And our question said the smallest, the least positive integer for the difference between two positive primes. Well, we have it here. The answer is 7. I mean, we can go further, 2 and 13, and that would be what? The difference of 11. And I believe you will not have 13. So even though 13 could satisfy our question condition, but then it said the least positive integer, so 7 is qualified.